Hello! How many of you have heard about WebAssembly? Great, most of you. How many of you have tried doing something with WebAssembly? One hand, that's really good. You're at the right place. WebAssembly is compiler target for the web. It allows us to compile from languages like C or C++ or other static type languages and run this into the browser. It allows us to reuse code and create really high performance applications into the browser out there. And when I say compiler target, what does it mean? You are aware today that if you write your application, let's say in C, you can compile this maybe for Linux, for Windows. But with WebAssembly, you can reuse the same source code and compile this and run it either in the browser or into a Node.js environment. It's exactly the same source without modifying it further. If, as a developer today, we want to basically distribute our application to as many people as possible, what we usually have to do is we have to compile one version for Windows, one for Linux, one for Mac. But unfortunately, this is not that simple because we are not only compiling for a certain operating system, we are also compiling for a certain instruction set on this operating system. So our task as developer becomes quite complicated. With WebAssembly, what we can do is we can reuse the browser's virtual machine to spread our application. So we have only one compiling target, and then the browser's virtual machines will take the rest for us. If we look at this very simple function written in JavaScript, it adds two numbers. Or I wanted to add two numbers, because JavaScript is a highly dynamic language, so even though I see this plus as adding, it can be anything. A and B could be integers, could be strings, could be objects, everything. And the virtual machine today has to take into considerations all these possibilities. And if you think that adding numbers could really be translated to concatenating strings with other things, if you start playing a bit with mixing types in JavaScript, you could really get into a very bad state of the mood. And at the end, it really spreads on your body and becomes really hard to get out of this bad mood. So this is only for experienced people. Well, WebAssembly is a type language. We work with numbers. We have integers and floating points in this time. WebAssembly is furthermore a binary language. So the same function that I showed you before looks like this in WebAssembly. But we are human, we are developers, and we can't really work with that, although we love numbers. So fortunately, there is also textual representation of exactly the same program. The textual representation is mainly for us developers. When we open the browser and see, let's say, view source, we'll be able to see this textual representation. But browsers, they will only work with the binary representation because it is the most optimal one. Why is it this? If we take a look at what's the process of loading JavaScript application today, it looks something like this. We have to fetch the JavaScript, then we have to parse it because JavaScript is a textual language, and then we have to do some compilation and optimization. JavaScript is a dynamic language, which means that the browsers, the virtual machines, usually they employ different heuristics to see how your functions execute. And if they see some pattern, they try to use the just-in-time compilation in order to compile it further to native where your code becomes really fast. For WebAssembly, the same process will look like this. We'll have to fetch the same program right there, and if you consider similar application sizes, WebAssembly tend to be smaller than JavaScript. Even if you apply compression, it becomes even better. Then, because we work with binary, so we are going to decode, and decoding is faster than parsing. This is also one of the points where we get a really nice optimization out there. And because we have already compiled to WebAssembly, which means that we have applied a lot of optimizations to our code, which means that the browser will do less for that. So we shorten the next stage as well. And as we're dealing with the type language, we don't really need to apply any heuristics. We know that the types are there and the browsers can rely on that. You can see that at this point, WebAssembly doesn't have a garbage collector, which means that if you are writing in languages like C# and Java, you need to port your own garbage collector into the browser today. But we can do even better than this, because WebAssembly comes with something called streaming initialization, which combines the first three phases into one. Because of the structure of the WebAssembly module, we can combine, while we are downloading the bytes from the network, we can already start really decoding and compiling this. And this shortens really the entire lifecycle for your application. WebAssembly is a standard. Today, if you have application written in JavaScript, you can't really reason about how fast it's going to perform, because different virtual machines, they apply different types of optimization. You don't have a standard way. With WebAssembly, this will be different. You have a standard implementation, and you could really reason about how your application would perform on the different conditions much better. There is a guy who made a really interesting animation of some robots walking and dancing on the way and coming very closer to you, hopefully not going out of the screen, not for now. And then he tried to measure how this is going to perform. So he did it in JavaScript and in WebAssembly. And the results are really striking. There are so much improvement between the JavaScript version and the WebAssembly version. Then you may think, oh my God, WebAssembly is so fast. And you're right, it is fast, but not everywhere. There are some situations where WebAssembly is not fast yet. This company, they do PDF viewer in the browser, and their current implementation is with JavaScript. So now, recently they started experimenting with WebAssembly, and you can see that the lower version is the faster. So it's not really everywhere where WebAssembly is faster. Fortunately, browser vendors are working towards making this even better in the future. You remember probably these old days where we tried to port different code into the browser. We were not really used to writing JavaScript. We wanted to reuse our coding skills in Java, or we started using Flash at some point. But the problem with this was that the user had to download third-party content to keep it up to date. It opened security holes. It made the user experience not so good. With WebAssembly, we are going to share code just like that, because it's a standard, so end users, they won't need to download any kind of plugin or install it into the browser. So what can we do with WebAssembly so far? Well, we can run Windows into the browser. Yeah. So if you are you have feelings about the old versions of Windows, you can go out and play with it out there. And if you are really a big fan of old versions of Windows, you can go out and play those games into the browser as well. So this is possible to do today. Actually, this is one of my favorite DOS games, and I am very happy to see it into the browser today. You can do something also very important out there. You know, the Vim community, they have one big problem, is to attract new people, is that most new users of the Vim editor, they don't know how to exit once they enter it. WebAssembly solves this problem quite easily, because in the browser you can always close the tab right there. So this is a really nice application, I believe. How can we start? What is the easiest way to start with WebAssembly out there? Well, the easiest way is using so-called WASM fiddle. You know, which you're used to work with JavaScript fiddle, for example, or CSS fiddle. There is also a WASM fiddle for that. And it's really easy to go. You can write code in C and C++, compile it, test it there, and see how it really works. For a bit more complex applications, you'd need a better toolchain support. And there comes Mscripton. Mscripton is a tool, or a set of tools, that enables you to compile from C and C++ and run this into the browser. So if you have really huge code base written in, let's say, C or C++, Mscripton is the way to go, because it adds a lot of helping functionality for you out there. And the way it's going to work is basically you replace if you're used to compile with GCC, the only thing you do is replace this with MCC, which is Mscripton's compiler for that. It's that easy. How does it work? Well, we developers, we are used to thinking components, modules, namespaces, And the same thing will apply also to WebAssembly. WebAssembly comes into WebAssembly module. So the output of your compilation is a module that you can load into the browser. And as every module, we can have some dependencies. So we can have things that we would need for our module. And then we can export some kind of API from our module that can be used. The same things are called imports and exports into WebAssembly. By the time of initializing your WebAssembly, you can provide a JavaScript object with functions, constants, whatever, that WebAssembly can use. And the opposite, you can also export some functions which you can call with JavaScript afterwards. Talking about imports and exports, there is one special import out there, and it's called the memory, the linear memory of WebAssembly. The linear memory is just an array. It's an array with a specific bound, so it has a start and an end, and this is what you are supposed to do. If you're writing in C, you're probably used to deal with memory. And in the browser, you don't really want to think about memory, because when you mention memory, most of the people really think, oh my God, something's wrong is happening there. But the good thing is that WebAssembly makes this really secure, because our memory is just a JavaScript array. And the WebAssembly virtual machine makes hard checks whether you are accessing the bounds of this array and nothing else. So you can't really see the memory of other WebAssembly modules running on the same page if you want to do this. Because WebAssembly at this point supports only numbers, what are we going to do with strings? Let's say we use strings for some stuff, right? And this is where the memory becomes really, really useful as well. Because the way to deal with strings right now is to put the string onto the memory. Basically, you need to encode it in one or another way. And then if you call your exported function from JavaScript, what you're going to get is just a pointer to this array, which is a cell in this array. And then you have to go there, decode this, and use the string for whatever you need. It's kind of tricky to do this, especially if you have a lot of strings. But fortunately, if you use mscripten to compile, it gives you these things out of the box. So it gives you a lot of tools in JavaScript directly to work with your WebAssembly without you needing to write this code every time. How are we going to load WebAssembly? Well, if you have a WebAssembly compiled module, we have to fetch it, as we said before. Then we have to turn this into array buffer and call the function WebAssembly.instantiate, where we provide this array buffer plus our imports if we need to or if we want to. It's completely optional. And then at the end, we get our instance on which we can call our exported API. This is like the traditional approach. If you want to use the streaming API, it becomes even easier, because you just call WebAssembly.instantiate streaming, where you provide the promise of your WebAssembly, and then it will do the rest for you. So remember that you don't have to wait until the whole module is downloaded to start compiling it. You can start further. When WebAssembly appeared, a lot of discussion started about what is happening with JavaScript right now. Is WebAssembly going to replace it? Are we going to start programming in languages like C and C++? The good thing is that JavaScript will be here. We have spent the last couple of years, more than 10 years, in educating ourselves, growing these communities, coming from the browser also to Node.js environment. We have spent really a lot of resources of developing JavaScript as a language. So I don't believe it's something that is going to distinguish, at least for now. But WebAssembly comes here to fill some gaps that are kind of weird to do with JavaScript. You can do everything with WebAssembly that we can do with JavaScript and vice versa. So you can't do anything more than that. But you can do some things better and faster, and you can reuse code. One thing is certain though. WebAssembly is going to change the way of web development as we know it today. Now we don't only have JavaScript code running in the browser. Now we can have any kind of language running into the browser because we have compiled to WebAssembly. How many of you are not using a JavaScript framework today for development? There are a few of you, yeah. There are situations where we don't really need. But for most of us, we use some kind of framework. We use maybe Angular, React, Ember. because these frameworks, they allow us to create enterprise applications into the browser. They allow us to structure our code better, etc., etc. And these frameworks, they already started looking into how WebAssembly could benefit for them. Vue.js and Ember.js, they started rewriting parts of their core into Rust and compiling this to WebAssembly in order to boost the performance when compiling and doing different kinds of optimizations. So there are situations where you can really benefit from WebAssembly, and you have to find these scenarios. You need to experiment. As we saw before, WebAssembly is faster than JavaScript, but not always. And we need to really find an isolated case where it really makes sense to use WebAssembly. I started for some time ago just to make a really fun project. Basically, I created a simple Angular website, and then I started searching on GitHub, finding different old projects written in C and compiling this to WebAssembly. So how does it work? Let's see. So, this is very, very simple website written in Angular. And all these here, these are applications written in C that I have compiled to WebAssembly. Even though I use Angular for this example, you don't really have to. You can do the same with React, Ember, or just without any JavaScript framework. You don't really need to do this. But this was for me like a proof of concept what we can do. So what do we do? Well, for example, you can do like this. If you like ASCII, this is probably your favorite tool to play around it. So you can just call this function and get the output for it, right? And remember, this is written in C. If you want to see the code, you can do this in Google. And again, it's not me who wrote it. So if you are unhappy with the C styling, you can, of course, complain for that. You can do also 3D visualization. Of course, there are cats for cat lovers there, right? Or you can maybe, because we are in Ukraine, of course, there should be some Vareniki, right? And also, probably you, if you were here for the Dennis session about mining, you probably are familiar with the proof of work algorithm. So this is, I found a really old algorithm written in C++ and compiling. So the idea here is that, as you saw, you can write some base tag, and then you can put a challenge how many leading zeros you want to find out there. So you can see that for one leading zero, it's very, it's very simple. So you can see only after 40 iterations, he found the hash that has one leading zero. If I put it in 2, things get a bit more complicated. It will take a longer time. I know this is very old algorithm. It's not really optimized at all. Something that I found, and I thought it was funny to port it to the web to run that. So, it took quite a lot. If I put this to 3, probably we are going to wait quite a lot for that. One thing WebAssembly is doing is not only affecting the current JavaScript framework. WebAssembly is also introducing new frameworks to the web. Now that we can program in different languages and put this into the browser, we can actually carry on different frameworks in different languages. And Blazor is one of these frameworks. It's written in, basically it allows you to write code in C# and ASP.NET MVC, the Razor syntax if you're familiar with that, and run this into the browser. So basically, you write your code really into Visual Studio if you work with that. You can compile this and run this into the browser right there. And I was also interested to see how different these concepts are from what we know on the JavaScript world today. So I created a different demo out there that I created the same application both in React today and in Blazor right there. It's a very simple application. It's kind of like a chat client that uses your local storage to write the thing. So if I say something like hi, and these applications, they're completely independent. The only thing that is linking them, this is your local storage. So they kind of really check your local storage every second and try to see if something is sent. So you can see it is counting the seconds out there. So I can write also something in Blazor and put this into the session again, and it will add it out there. The development experience is very, very similar. If you use React, you know that we have different components. and we structure our code in these components. The same things, they are also applied in Blazor. The only difference is, of course, that you write in C# and using different language for visualizing it. But this runs into the browser. There is nothing server-side for that. And Blazor was just one of the first ones. After Blazor, many people really started playing around with it just to see how it works, what it can do. Of course, for very simple applications, it doesn't make sense because you add too much overhead, but we are not writing hello world applications anyway as developers. We write business applications, big applications. And Blazor was just the first one on this movement. Afterwards, people started writing their own frameworks in Go, let's say, which got WebAssembly support here recently in August this year. This is also an example how we can build client-side applications in Go. Or we can do the same in Rust. Rust is also a very modern language that allows us to compile to WebAssembly. So we can do this. And even if you think that these names are quite interesting for these frameworks, I mean, there is also Spasm out there. So maybe when you program in this, it's called the D language. It's very funny, by the way. You may get Spasm out of this. It's a nice name anyway. The question is now, how secure is WebAssembly? We want to know. You remember probably that at the beginning of this year, we had a really big issue with the Spectre and Meltdown issues, right, with the CPU. And this really made the point, what is the future of WebAssembly? Is it secure enough that we can use it? The good thing is that WebAssembly is not going to be affected by that. However, there is one part of it that will be really postponed, and this is the multi-threading part. Now you can't do multi-threading in WebAssembly. It was supposed to be part of the standard in the future, but with these issues that we got, this will be postponed in the future. So now what we can do is we can put WebAssembly in a web worker, let's say, and use it this way to support some kind of multi-threading. The good thing is that WebAssembly reuses everything that we have done for JavaScript. JavaScript runs is a sandbox. The same is applied for WebAssembly. We can't do anything with WebAssembly that we can't do with JavaScript, right? So we are reusing all these security measurements that we have already done for JavaScript today. Question is, how spread is WebAssembly? Well, the good thing is that all the modern browsers support it. And the reason for that is that WebAssembly, since the beginning, it became a joint venture, which means that Microsoft, Google, Mozilla, they stand behind this together with really big community of developers out there. So already from the beginning, we have the browser vendors supporting this project instead of doing their own. And this really makes WebAssembly so successful that all the browsers are already implementing it. So you can basically open any browser and use WebAssembly without a problem right there. Now it's interesting to see how many languages can we use right now. I mean, I mentioned C and C++, but well, what about the other languages? I mean, there are so many other languages that we can use. And to try this thingy, this concept, I created another project which I called the Wheel of WebAssembly. It is kind of like the Wheel of Fortune, if you know the idea out there. The only difference that you don't really win anything from that. But what you can do is you can compile. So all these parts that you can see out there, these are languages, right? So you have the Kotlin, Go, C#, etc., that I have compiled to WebAssembly. They expose exactly the same API. And this API has basically two functions. One function is tell me your name. So I am C#. And the second function is generate a random number between 1 and 100 for me. And all these languages, they export this function. So I can come here and I can spin the wheel. And now it will generate a random number. So 21, this is random number generated by calling the WebAssembly of Rust out there. And these web parts, they're completely isolated. So they don't know anything about each other. And they work on the same page together, right? Manipulated with a bit of JavaScript. So WebAssembly really allows us to bring different languages and use them independently. So you don't care what language your source is written in. You only care about the API of WebAssembly. And this is really, I believe, the power of WebAssembly. And I kind of, looking at this project, I mean, I was very happy every time I saw that a new language got a support for WebAssembly, because I started immediately playing around with it and trying to compile it to WebAssembly to see how the developer experience for that is. And of course, the best developer experience so far is for C, C++, and Rust, but the other languages are slowly improving their compilation tool chains for that. And one of the last weeks here, I saw one of my favorite language went into the browser. So now I have one more wheel part that I can add to the wheel of WebAssembly, because now you can run PHP into the browser and it really runs there, right? So this really makes my project feel very good, and I get a nice feeling for that. WebAssembly brings something different out there. It allows us to reuse code in many different languages and run this into the browser. It allows us as developers to reuse our skills in different languages and apply them in situations where it really makes sense, in situations where we want to work with numbers, want to make things really fast. It could be gaming industry, it could be CAD, and so on. So I really believe WebAssembly is a game changer on the web, and it allows us to make our web really more diverse. My name is Boyan. Thank you so much for coming here today.